Okay.
Okay, good morning, everybody. As you all know, today is World Zoonosis Day, and I'm supposed to give you a lecture on zoonoses. It's because it's a bridge between human and veterinary medicine. By the way, my name is Dr. Ezenduka Ivi. I'm in the Department of Veterinary Public Health and Preventive Medicine, University of Nigeria, Nsukka. As we all know, has a link with animal health and animal production. And this linkage, you can see it, or should I say our association with animals has to do with what we do as veterinarians. We produce meat for humans to consume, and then the animal, for several reasons. They use their fur for clothing, they use the hide and skin for clothing as well. Now, sorry, this thing has refused to move. Okay, we also use pets as companions with our animals. We use pets and companions, but this close association we have with these animals is risky. It's beneficial and it's also risky. A number of communicable diseases are transmitted from animals to humans and then humans back to animals. This is actually what is called zoonosis. Now, this is a layman's definition of zoonosis. That is the transmission. Now, we have a bigger definition by WHO. WHO has defined zoonosis as those infections that are naturally transmitted between vertebrate animals and humans. Vertebrate animals and humans. Why we're stressing on vertebrate animals is because you don't call those diseases as, you don't call them zoonosis. In this case, vertebrates must have to be involved. Vertebrates must have to be involved. For example, you can't say that malaria is zoonotic because malaria, you get it directly from an arthropod. But if malaria affects a vertebrate, zoonotic. But as long as it's a disease that does not affect both vertebrate animal and man, you can say it's a zoonotic infection. Now, why zoonosis is very important is because out of all the diseases existing in the world that we know of, 60 to 80% of them are actually zoonotic. In other words, there are more than 250 zoonotic diseases. We don't know, but the ones that we know, more than 250 of them are actually zoonotic. But there's another important thing we should note. 75% of all emerging diseases are zoonotic, are actually newly evolving, or diseases that have come once, eradicated or disappeared, and reappeared again. Such diseases like avian influenza, SARS, MERS, Ebola, and now coronavirus. So you can imagine the extent of what zoonosis can do. That means that most emerging diseases, when dealing with them, veterinarians have to be involved, not just human doctors. About common diseases, because there are so many of them, so we can't cover all, but there's very common ones that one or two people must have heard of. Now we have to classify them based on the nature of the etiologic agent of the disease. Now we have, we mean those of you in 40 year will of course know, those in 40 and 50 and final year will know what I'm talking about. Bacterial origin, it could be a rod-like, it could be cocci, it could be spiral. An example is anthrax. You know, anthrax is caused by Bacillus anthracis. And then we have brucellosis, which is caused by several Brucella organisms. And then tuberculosis caused by Mycobacterium tuberculosis and Mycobacterium bovis. Now we have other ones from viral origin. What you're looking at, picture you're seeing now is actually a picture of, should I say coronavirus picture? Yes, it's coronavirus. Now zoonosis is rabies, yellow fever, and then we have Ebola. Then it can also be of parasitic origin. I'm sure most of you have heard of trypanosomosis, fasciolosis. Trypanosomosis is quite common in Nigeria. It affects a host of animals, not just cattle, but sometimes when you go to the clinic, you may see a dog that has strips. It's quite common. And that's a picture of a parasite that should be a kind of protozoan. Now, our focus on zoonoses is to focus on prevention and control of zoonotic infections. Why we as veterinarians should work or should have so much knowledge of zoonoses is that we're trying to prevent this transmission of these zoonotic infections from humans to animals and from animals to humans. That is a zoonotic agent. For you to know what to do, there are some strategies you have to follow. First of all, you have to know the epidemiology of that particular disease. By epidemiology, we mean what is actually happening. If there's an outbreak of a disease, what is happening? Where is it happening? Who and who is involved? Is it a disease that is affecting only females, or a disease that is affecting only males? Or is it a disease that is affecting whites, or is it a disease that is affecting only blacks? And then religion, is it a disease that is affecting only Muslims? Or is it a disease that is affecting Christians or idol worshippers? Such clues will help you to narrow down on what's the disease we're talking about. Now, you now check the clinical manifestation of this disease. It's very important for you to know the clinical manifestations of this disease, because that is where you're going to give your control strategy. Okay, before I go on, let me just give you the difference between prevention and control. Prevention is when you're trying to prevent the disease from spreading further, or when you're trying to protect an area from the disease coming in. So you're trying to prevent either the animal populace or the human populace from the disease. It means that the disease is already there. What you're now trying to do is to prevent the further spread of that disease. Assuming somebody has tuberculosis, the best way to control it is to treat that individual. And for you to treat that individual, you have to know the clinical manifestations of tuberculosis. That's why clinical manifestation is very important. And now, when you know the clinical manifestation of such diseases, you want to do a proper diagnosis. Proper diagnosis, if it's a bacterial infection, to know which bacteria is actually causing the disease, or you want to do things like serological tests, like ELISA, immunofluorescence tests, and the rest of them. That is proper diagnosis, because if you misdiagnose, that means you're not dealing with a particular disease. So you need to do proper diagnosis. Another strategy for prevention and control is knowing the life cycle of the etiologic agents. Now, most of the times, we attribute life cycle to parasitic zoonotic diseases. The life cycle of Fasciola, for example, Fasciola is a helminth. The life cycle of Fasciola agents, if you know the life cycle, you'll be able to know how to prevent the occurrence. Now, Fasciola has an intermediate host, which is a snail. Now, if you're trying to prevent the occurrence of fascioliasis, you now know that since you know the life cycle that a snail transmits the disease, what you do is to focus on how to limit the occurrence of the snail, and then focus on how to limit the growth and the increase in population of the snail, that particular species of snails. So what you do is to depopulate the snails. By so doing, there is no way the snail will get on herbage, if it's not there, get on herbage and to release the organism on herbage. I know in fascioliasis, how man gets it is when man eats herbage. By herbage, we mean maybe cabbage or lettuce or all these herbs that we eat. Now, if man eats herbage that harbors that organism that was released by a snail, that is how man gets infected. So it's very important for us to know the life cycle of the etiologic agent. So we now know how to strategize and to prevent the occurrence of the disease. Now, life cycle also works hand in hand as transmitted before you can issue a preventive strategy. Now, these are ways diseases can be transmitted. It could be through aerosol. Could be through aerosol. By aerosol, we mean inhalation of droplets. These droplets may contain the infectious agent. So when you now inhale them, you're, should I say, infected with the organism. Now, diseases that you can get through aerosol, something like tuberculosis. When somebody has tuberculosis, is close to you and the person sneezes, the droplets of the tuberculous organism, you inhale it and then you get infected with oral. Oral is very common. If, like we do meat inspection in the abattoir, now when you get to the abattoir and you don't do a proper meat inspection and the meat that is exposed for consumers to consume is infected with certain zoonotic organism. When consumers consume it, they now get the infectious agent from the meat. It's not only from meat, even from milk, from egg, any animal byproduct or any animal product. So it's very important for us as veterinarians to do proper meat inspection to avoid. Now you can also have transmission through a vector transmission. Remember I said in zoonosis, if you have direct transmission from an arthropod, you don't call that disease zoonotic. But if the vector, what it does, or the arthropod, what it does, is to bite a vertebrate animal or feed on a vertebrate animal that contains the etiologic agent, and then also feeds on man, that is when the organism is being transmitted into man. Okay? Now we also have direct contact. For example, when you are exposed directly to the etiologic agent, in cases of like what we're showing here, I think is a case of brucellosis. In cases of brucellosis, when you have, and then you have aborted fetuses littering all over the place, and you as a veterinarian, you don't protect yourself very well, you don't wear gloves, you go touching the aborted fetus, you're exposing yourself to the etiologic agent of brucellosis. Now, we also have contact through fomites. This, should I say, it's very, very important, and most of the times is of occupational hazard. Because if you are a veterinarian and you work hand in hand with animals and use some certain equipment in dealing with those animals, like if you're milking an animal and use a certain equipment to milk the animal, and you expose yourself to such equipment, such equipment is called a fomite, because it is harboring the organism, the zoonotic organism, and then when you now touch the fomite without properly clothing yourself, properly covering yourself, you get contaminated, and from there you go down with infection. Okay, so let us deal with the very common zoonotic infections that we know. I'm not going to go very deep into it because there is no much time, so I'm just going to rush it, but people have to listen very carefully.
Okay, thank you so much. I would like
tuberculosis is a zoonotic.
Hello.
Is someone saying something?
Yes, I would like you to admit some people. Some people are still waiting. As I'm not the host.
No,
again,
you can admit them. You can admit them. Let them join the meeting.
Okay.
Okay.
I can't.
While I continue, you can admit them.
I couldn't admit them because of.
Okay. Okay. Let me check the waiting room.
All right.
Okay. I've admitted them. They're joining now.
Okay. Thank you, ma'am. You can continue.
Okay. Should I continue?
Yes, ma'am.
Okay. So we are talking about tuberculosis. Okay. We're talking about tuberculosis. Tuberculosis is a zoonotic infection of bacterial origin. It's a chronic disease in both humans and animals. Tuberculosis, I can tell you, is no joke because it's very expensive to treat and it takes a long time to treat. So the best thing to do is to prevent the occurrence of tuberculosis ab initio. Now, tuberculosis is caused by Mycobacterium tuberculosis. That is the one that actually affects humans. And the one that affects animal is Mycobacterium bovis. In other words, it's a zoonotic infection because both Mycobacterium, man and human. That is why we say it is zoonotic. Now, the basic ones that we know that can cause tuberculosis, Mycobacterium tuberculosis and Mycobacterium bovis. But there are some other ones. We have Mycobacterium africanum, which occurs particularly in West and Central Africa. And then we have Mycobacterium microti, we have Mycobacterium caneti. All of them can cause tuberculosis. Bacterium tuberculosis complex are those ones I have already named, the Mycobacterium africanum, the Mycobacterium microti, and Mycobacterium caneti. They just call it Mycobacterium tuberculosis complex. But the principal agent of zoonotic tuberculosis is actually Mycobacterium bovis. That's the one we get from cattle. And most, okay, let's talk about the transmission of tuberculosis. It is aerogenic of droplets of the microorganism. If you have the microorganism in the dust and there is any activity that goes on the ground, you can inhale the dust. Or if someone that has tuberculosis beside you and the person sneezes, you can get the droplets, you can inhale the droplets. Or if you're working with animals and you're in a very congested place, then you can also get tuberculosis by oral route. When you consume milk from infected meat or unpasteurized milk, this is very, very important because sometimes when you observe Fulani cattle bearers, most of them drink milk directly from their cattle. This milk they are drinking directly from their cattle is not pasteurized. And not just that, this milk they use in making nunu. I hope people know what fura de nunu is. The milk, the raw milk they use in making nunu, most of them are not pasteurized. So when they milk a cattle that has it, I can assure you that you can get infected with tuberculosis. Now, what we're trying to do here is, remember I said the focus of zoonosis is to know how to control and prevent its occurrence. So let us go to control of tuberculosis. Sorry, I think more people want to be admitted. Okay, control of tuberculosis. You have long-term treatments with these drugs, but it's actually depending on the resistance of the strain to these antibiotics, and it takes time to treat. So the best thing is to avoid consumption of raw milk, cook your meat very well before consumption, and make sure there's proper meat inspection. Actually, sorry, this is not infection, this is inspection. Make sure there's proper meat inspection in the abattoir so that the populace do not get to consume contaminated meat. Now, I've given you an example of a bacterial zoonosis, that is tuberculosis. So let's go through an example of viral zoonosis. Is a member of the Lissa virus of the family Rhabdoviridae. It is a single-stranded RNA. Let's not go so much into that, but that is the structure of the rabies virus. Now, rabies, we have those animals that are reservoirs of rabies. We have the wolves, we have the skunks, and have the foxes, we have the raccoons, and then we have bats. It's true that we're not in close association with other these wild ones, but somehow we are in close association with the bats. But most importantly, dogs and cats, they serve as the most important sources of human infection because of their close association with humans. Use them as pets. So how is rabies transmitted? Rabies is transmitted to human through the bite of a rabid animal, mostly dog or cat. Then you can also get rabies through contamination of wounds or mucous membrane with infected saliva of a cat or of a dog, or even of humans that have rabies. The disease does not actually spread from man to man, so to say, because humans don't go about biting others. That's why you don't have that. Okay, so, but you can also have transmission when you have organ transplants. If they transplant the cornea or other organs from an infected human to another, you have transmission of rabies. And then some people say rabies can be gotten from aerosol, from inhalation. People got one or two cases where people got infected by aerosol. They entered a cave where you have bat colonies. I know such caves would be humid, and due to the humidity, there's of course release of exudates from those bats, and somehow they got to inhale that and they got infected. So that's why they say you can have aerosol, but it's quite rare. Okay, how do you control or prevent the occurrence of this disease? Vaccination, the shout or the craze for vaccination is never enough. We keep saying vaccinate your pets, vaccinate your dogs, vaccinate your cats. Now, we vaccinate using live attenuated flurry low egg passage in adult dogs. There's something we call low egg passage, and we have high egg passage. In adult dogs, we use low egg passaged vaccines. Then in puppies, in cattle and cats, we use high egg passage vaccines. Then in man, if there's anybody that has rabies in man, most times when somebody start treating on time, well, the person may survive, but the survival rate is not quite much. It's low, it's very low. So, but once symptoms develop, treatment virtually always is unsuccessful, as I said. And then you have intensive supportive care. Only 6 cases of documented recovery. So you can imagine only 6 cases out of so many cases they must have had. Only 6 cases have been documented as being recovered from rabies. And 5 of these received some type of prophylaxis before the onset of symptoms. Now, the best thing for those that are occupationally exposed to rabies, those that are working with dogs and cats, especially veterinarians or animal health superintendents or farm hands, those that you know that at any point they may be exposed to rabies, you have to take pre-exposure immunization. pre-exposure immunization with animals. Please go and take pre-exposure immunization. Okay, that's for rabies. Now, but another thing I have to mention is the best way to prevent the occurrence of rabies is to do mass dogs. Sometimes during World Rabies Day, we go about catching stray dogs and vaccinating them against rabies. Okay, so that rabies was, of course, viral infection. So we're talking about parasitic zoonosis. Trypanosomosis, we have American trypanosomosis, we have African trypanosomosis. So American trypanosomosis is culture gas disease, but our focus here now is African trypanosomosis, which is caused by T. brucei gambiense and T. brucei rhodesiense. T. brucei gambiense is the chronic form which occurs mostly in West and Central Africa, and that's what we have in Nigeria, T. brucei gambiense infection. Now, T. brucei rhodesiense occurs mostly in East Africa and is the acute form of the disease. Remember I said earlier that if you want to give a good control, you need to know the life cycle of the etiologic agent and the transmission. In this case, the life cycle or the intermediate host, should I say the vector that transmits trypanosomosis, we have Glossina palpalis, we have Glossina morsitans. Now, Glossina palpalis is the one that transmits T. brucei gambiense. Glossina morsitans transmit T. brucei rhodesiense. Now that we have an idea that Glossina transmits trypanosomosis, the best way to prevent the occurrence of trypanosomosis is to reduce the population of Glossina so that they don't prevent the occurrence of trypanosomosis. First of all, as I said earlier, you have to reduce parasite population by therapy, by treatment. Remember, I said you have prevention strategy, you have control strategy. In this case, treatment is a control strategy. You have to treat those animals or those humans that have trypanosomosis first so that you reduce the parasite population. Now, another way is to reduce the vector population. How to reduce vector population is by using traps to catch the Glossina organism. Glossina, another name for Glossina is actually sassafly. That's what we call sassafly. So it's either you use traps or use insecticide sprays or you clear breeding sites. You know, they like staying in bushes. So when you population, and then of course, if you have to be very careful, you have to avoid areas of endemicity. But if you must go into the bushes, if you're going camping, if you're going picnicking, please try as much as to cover yourself with personal protective against the vector. You wear light colored clothing that cover your arms and legs. The idea is that you may not be bitten by Glossina. That's why you have to cover your legs and you cover your arms and legs. And why they said light colored clothing is because somehow they repel the Glossina. They chase away the tested because they don't like bright places. They like very dim. They feel is light. They don't